Okay, welcome back to this video. I want to thank those people who have taken time to subscribe to the channel. Please, if you haven't subscribed, please help me and subscribe to the channel. It is really like fuel that fuels me to make more videos, to make more content, and to read more and research more. So thank you very much. Please subscribe, leave a like, a comment. I appreciate it. Thank you. Now, if you watched the previous video about scanning through strings, you remember that we used this function where we are using pattern matching in Rust and comparing through the bytes of the string and print out the corresponding characters underneath and their corresponding ASCII codes. We looked at that in the previous video. Now, this code is somewhat a bit complicated, and honestly, it is not easy to read if you look. But we can have a simpler representation of this code. And that brings us to the concept of using iterators in for loops. Now, if we rewrite the same code that does previously what we are looking for here, so we can say function, we can call it print codes, maybe simplified, and it takes a string also, a string S, which is a string slice or string reference. And this time round, it is going to be using a for loop. So for I or for C, whatever you want, in s.chars, so we use this s.chars, which is sort of like an iterator itself. And then we want to print out, of course, the corresponding strings or characters within that string. And then also we want to print out, we want I, and then I as a U32. That's some sort of like casting. So basically what we want is, we are still like printing out the same thing, but we have minified this entire function and made it simpler to read. So we are saying that even iterators can be in for loops. Basically, that's what we are saying. And invoking this function, we're still referring to this string. We can use S1. So invoking the print simplified, we call S1. And then running this here, calling main Rust function, so the Rust compiler /main, we see that we literally end up with the same thing as here, as print codes. So we print the character and the corresponding ASCII code. Now, that shows that we have created a simplified version. So this program generates the same machine code as this one above. But it is much clearer. Like this one is more readable and more comprehensible if you think about it. So we come to look at that, but we also want to look at the concept of mutations within iterations. And you can see that previously what we've been looking at is like, so far we've used iterators only to read the sequences, and this is mainly what most people do. Like we would say it is typical. So we want to look at an example where we don't have mutations or changes within the underlying sort of like sequence. And even here, for these two functions, ideally we haven't mutated anything. For strings, you really don't want to change anything, I would say, maybe in some cases. But we want to look at iterations where mutation is not possible. And the reason why we are looking at this is because of a behavior that happens within mutations where the iteration over a given range is only using the range value, the range value at the beginning of the loop. Let's demonstrate this. So we can put this in the main function, and we can create some space there. So we say, let's create a mutable sort of iterator, error. I hope we don't have error above. Error equaling to maybe abc.chars. Yes. So, what do we want to do? We want to use a for loop. For I in error, what do we want to do for I in error? Error will equal to a new iterator. So we are like changing error or reassigning error within the loop. And we want to see the effect that this causes. That chars. And then we want to print out, of course, we want to print out the values in error, and the sort of the corresponding positions within the new range. We need two formatters there, and this will be we need I, we need R, we need r.next.unwrap. This is good. So we need to point to the values here for corresponding values here, and that's what you want to see. But let's look at the result. And beautiful, excuse me. So we see that we are getting for every value in the range error, the original range, A, B, and C, the iteration is like it's constant. It remains, it points at X. And that's what that mutation is the one that I wanted to demonstrate here. So what does that mean? It means something that for every iteration within error, within the loop, so when we are on I, when I keeps on changing, we go through error. But we are reassigning error. And when we reassign error on every iteration, it's like we are pointing to the first value within the range. That makes sense. But if you want to appreciate it more, let us look at another good example that will bring it out well. Assuming we let R1 equal to this given range to 5. Okay. And remember, R1 is now not mutable. And so we say for I, but for I in R1, we want to increment I and then print out I. Let's see this behavior and see what comes out. What do you expect is we don't expect I to change. Let's run this again. There's a problem here. For ref mutation in error, even the compiler is refusing. So it's telling us that for you to, this is the beauty of Rust. Like for you to have something inside here, this I should be mutable. And when you read, the problem is saying error cannot assign twice to immutable variable RI. So it's not, you cannot reassign, like we are reassigning, we are mutating the immutable error here. So if we make that mutable, running that, get no problem, and then calling this. So we see that we are printing out from 10 to 14, meaning that we are incrementing, we are able to increment this from 10 to 15. But the beauty here is when you look at underneath, ideally, the range is not getting mutated. Like the real change is not happening on the range. And outside this for loop, R is still the same. I hope that makes sense. So we wanted to demonstrate that use of mutation within for loops. And thanks guys for watching. See you guys in the next video. Please leave a like, subscribe, leave a comment, and see you guys in the next video. Bye-bye.